So section 2 of this discussion will focus on some examples of the order of the results. And in particular, we're going to talk first about collections and how the type of collection that's used as the source of a stream can affect the results order. Now, there's a couple different types of collections, and these collections are achieved in terms of ordered splitterators, ordered collections, and then certain static stream factory methods like of, for example. And we'll talk through this, and we'll first start by talking about the ordered collections. So here's an example where we're going to make ourselves an array list of elements in the order 3, 1, 4, 2. So that's the encounter order. So the encounter order is 3, 1, 4, 2, and that's because this list is ordered, or an array list is ordered. Now don't confuse ordered with sorted. Those are two different concepts in streams. Ordered just means, you know, the first location, location 0, is 3. The second location, location 1, is 1. The third location, which is index 2, is 4, and so on. That's the encounter order. And an array list is ordered. So when we say list.parallelStream, this source is an ordered collection. Not sorted, but ordered. And what we do now is we go ahead and we get rid of anything that's an odd number. We filter out even numbers. We only let even numbers through. We filter out the odd numbers. We then multiply every number by 2. We double it. And then we go ahead and call a terminal operation called toArray that will create an integer array, and it'll store the results into this thing that we call doubled list, because we doubled each of the elements that were even. Probably should be called even doubled list. And the results in the even doubled list must be 8 followed by 4, because of course those are the two even numbers that survived the filtering process. And that's because list is an ordered collection. It keeps track of the encounter order. Okay, so far so good. That makes some sense. There are other kinds of collections, however, that are not ordered. They're unordered collections. Surprise, surprise. And an unordered collection just means that the collection is not obliged to store them in any particular encounter order. So a good example of this would be a hash set. So if you give these values to a hash set, that is not going to store them in any particular encounter order. It's just whatever it hashed to. So the encounter order is set, the collection's property is unordered, because it's whatever the hash uses to distribute the values throughout the hash table. So when you say set.parallelStream, in that particular case, we now have a parallel stream for an unordered collection. And this result, which will give us the same result, will likely run a little faster because there's no need to preserve encounter order with the results. So the results are whatever the results are. So it could be, 8 followed by 4, or it could be 4 followed by 8. Doesn't matter, because a hash set's unordered. We as a user don't care, because we're not expecting encounter order to be preserved, number one. And number two, because it's not expected to be preserved, there's no work required to reassemble things in encounter order when you present them ultimately to the user as the result of the terminal operation. So that's an example of unordered collections. So hopefully that makes some sense.